It says, compared to an empty ship, will a ship loaded with a cargo of foam float lower in the water or higher in the water? So I'm going to pile foam in there. Is it going to sink a little bit? Still float, but is it going to displace more water or less water? In other words, will it be like this? We'll say A, or will it be like this? We'll say B. Which one is it going to be? A or B? If I put foam. Now remember, foam, like styrofoam, nearly has a density of 0. Certainly not quite, but pretty close. So I'm going to pile foam in this boat. Is the water level going to be at the water level at B or at A? Anybody? What is it? You say A? How many people say B? Raise your hand. Mohammed says B. You say B? Well, this is the answer. The answer is that it's going to be A. Because even though that foam has a density far less than that of water, it still has a mass, does it not? Doesn't it? Does that foam have a mass? Sure. Does it have weight? Does it? It has a weight, right? So let's do this. If you think about it, let's put the foam really high. Put pans of foam. Okay? And we'll make it 10 miles high. 10-mile high foam column. What's going to happen to the boat? Isn't that an enormous extra weight? Even though foam has a very low density, if I put a 10-kilometer column of foam in that boat, what may happen to the boat? I could sink it, couldn't I? Yeah, I could. Because it's a mass. That mass has a weight. That weight is going to add to the weight of the ship. It adds to the weight of the ship. It's going to add to the volume of water displaced. It adds to the volume of water displaced. It adds to the weight of the volume of water displaced. It adds to the weight of the volume of water displaced. It increases the buoyant force. If it's still floating, the buoyant force equals the weight, right? The buoyant force is greater, the weight is greater, correct? So it's got to ride lower in the water, correct? You get it?